Many techniques which are used for material characterization are spectroscopic techniques. Not all of them, of course, but many techniques are spectroscopies. This means that when we apply this technique, we measure some kind of spectrum. You can guess that word spectrum comes from Latin. But if you check the dictionary, you can find a number of unexpected translations, like a ghost, a phantom, or even a soul. Initially, this term was suggested by Isaac Newton when he managed to split the visible light into different colors using a prism. So he managed to see the inner structure of light, which is hidden in normal conditions. And in the same way as a person is supposed to have a soul, which is hidden somewhere inside but is not visible by other people, Newton suggested to call this a spectrum, meaning that he managed to see a soul of light. So I hope you enjoyed this story, but actually it was not the message to take home. And a message to take home today is the definition of spectroscopic technique, the very general definition. So in modern understanding, spectroscopy is an experimental technique in which we study interaction between matter and a particle beam by monitoring some kind of response of this interaction as function of energy of incident or outcoming particles. By particles, we will most often use photons. It can be visible light, X-ray radiation, or radio waves. It can also be neutrons or electrons. By energy, we can also use wavelengths or frequency or a wave number. And one common example of a response is absorption. For example, this bottle is green due to the fact that the photons whose wavelengths correspond to the green light can easily pass through, while all other photons are stopped. So this is an example of a simple spectroscopic investigation in which we monitor the absorption of photons in glass as function of their wavelengths.